Hello, and welcome to our presentation on debunking fire forensics. I'm Erin.
I'm Morgan.
And I'm Allison.
And stay tuned for our fiery presentation. The purported goal of fire and arson investigations is to determine where a fire originated, why it started, and how it spread. Fire investigators often have a mythical understanding of fires. They've said things like, fires don't destroy evidence, it creates it. Or, the fire tells the story, I am just the interpreter. Fire investigators claim that fire forensics is a, quote, systematic method. Generally, fire and arson investigators examine the physical attributes of a fire scene and identify and collect physical evidence from that scene. Ideally, this evidence is then analyzed to help determine if the cause of the fire was accidental or deliberate. During the scene examination and the lab examination, investigators may find evidence such as accelerants, tampered utilities, and specific burn patterns, which investigators say indicate criminal activity. This evidence of burn patterns and accelerants can then be entered as evidence during a criminal trial through the testimony of the expert witness, here a fire investigator. Fire has been extensively studied, but the complex chemical and physical processes involved are still not fully understood. While much is known about the behavior of fires in building enclosures, using that knowledge to determine where a particular fire started and what caused it remains very challenging. The scientific validity behind fire investigations is questionable, which we'll turn to next.
According to the PCAST report, a method is scientifically valid when the method has been shown based on empirical studies to be reliable with levels of repeatability, reproducibility, and accuracy that are appropriate to the intended application. The only way a method can be deemed scientifically reliable is through empirical studies. Empirical studies analyze a large number of independent sets of samples, similar in relevant aspects to those encountered in casework, in order to understand and estimate a method's repeatability, reproducibility, and accuracy. While a method's results need not be perfect, its accuracy and error rate must be a known result of empirical studies, and it must be high enough to be appropriate to the application. Without this information, it is impossible to interpret the results or how often the method is correct. Subjective methods, such as arson investigation, are measured by a particular type of empirical study known as a black box study. Black box studies have examiners analyze samples and render opinions about the origin or the similarity of the samples.
Here are characteristics of a proper empirical study.
Next, we'll discuss how arson investigation lacks scientific validity. First, it is conducted by people with stakes in the outcome. Fire investigators are often either employed by fire or police departments, and the lines between fire scene examiner and criminal investigator are not just blurred but are obliterated. In no other forensic discipline is the forensic examiner expected to determine if a crime has or has not occurred, or to determine evidence outside the examiner's area of expertise in order to identify a suspect, verify a suspect's opportunity to commit a crime, or develop a motive. Only fire investigation, particularly as practiced in the public sector, has embraced the merger of forensic examiner with criminal investigator, seemingly unaware of the pitfalls this potential bias creates. Second, fire investigation is conducted by people who do not have training in research design. In most states, in order to be certified, investigators had to take a 40-hour course on fire investigation and pass a written exam. Often, the bulk of an investigator's training came on the job, learning from old-timers in the field who passed down a body of wisdom about the telltale signs of arson, even though a study in 1977 warned that there was, quote, nothing in scientific literature to substantiate their validity. Next, error rate. The error rate in fire investigation is very high. There are not many studies looking at this, but the ones that have been conducted, we will discuss further in the fry argument section of this presentation, show that fire investigators correctly identify fire patterns at the same rate as random chance. Also, fire investigation is uniquely positioned to be impacted by cognitive bias, as identified in the National Fire Protection Association Guide for Fire and Explosion Investigation. Cognitive bias is a type of subjective bias that undermines the reliability of evidence and can cause an observer to see something that did not exist or to fail to see something that did exist. Fire patterns and burn indicator analysis are the key tools at the heart of most fire scene examination and are largely based on human interpretation and are highly ambiguous, especially where there is flashover, ceiling collapse, or extensive overhaul, which are very common amongst fire investigations. Fire scene examination is further conducted in the field rather than in the laboratory, making it hard to control for irrelevant information and additionally contributing to bias. The Arson Research Project conducted a two-part research study designed to measure the accuracy with which fire investigators were able to recognize the presence or absence of ignitable liquid on burn patterns through visual examination. The study was the first blind study conducted to determine the ability of fire investigators to distinguish burn patterns and fire indicators from full secondary flashover or a natural cause to those attributed to the presence of ignitable liquid. For participants who found that there was ignitable liquid, the accuracy score was just 50%. In another phase of the study, highlighted the danger of cognitive bias in fire investigation and gave participants a pre-questionnaire scenario that was designed to introduce expectation bias. One group was introduced to an eyewitness saying they saw a suspicious person carrying a sack and entering the house before the fire, and that group was 9% more likely to conclude the presence of ignitable liquid that caused the fire. The other group, on the other hand, was exposed to information that made it seem like the fire was accidental and that there were no injuries resulting from the fire. That group was 17% more likely to determine that it was an accidental cause of fire, showing that the conclusions tended to correlate to the biasing information. Concerningly, public sector investigators chose an insidious cause more often than their private sector counterparts.
For admitting expert witnesses, the judge has to make a determination of whether something is legally reliable, meaning it's scientifically valid. Judges make this determination by either using a Fry or Daubert analysis. Here, we'll be using Fry. The main question of the Fry test is whether the expert's testimony is deduced from principles that are sufficiently established to be generally accepted in the particular field in which they belong. We will be arguing that the relevant scientific community does not accept that fire investigation can reliably identify the cause or origin of a fire. The core Fry argument is over who is included in the relevant scientific community. We'd be arguing for the inclusion of a wide range of people from different disciplines. Specifically, we've critiqued the government's argument that only practitioners should be included in the relevant scientific community. Because what matters is that the relevant scientific community can understand the test and whether the method is valid, and fire investigators do not have that ability. As explained above, fire investigators are often either employed by fire or police departments and are not independent from those departments and do not have the training to ensure that a method is scientifically valid. With that in mind, we'd also want the relevant community to include academics, specifically academic scientists, fire and electrical engineers, chemists, physicists, psychologists, and statisticians. We point to the group gathered to work on the 2017 report published by the American Association for the Advancement of Science on Fire Investigation. The next question becomes whether there is a dispute that bars general acceptance. We'd say the relevant community does not accept the commonly practiced fire investigation can reliably identify the cause or origin of a fire. Fry does not shield a specific type of forensic science from review simply because it has been accepted in the past. Several recent advancements in the science and high-profile exonerations, along with the likely execution of an innocent man in Texas, have led to the community to further study fire investigation. And it hasn't been pretty. There are many, many issues with fire investigation. The relevant scientific community laid out its finding in a 2017 report from the American Association for the Advancement of Science, as mentioned above. The group found that the chemical and physical processes involved in fire are very complex and still not understood by anyone, let alone fire investigations who rely in large part on old wives' tales and wisdom in the accepted in the field. It is not only very hard for anyone to know the origin and cause of a fire, but the process of conducting the investigation relies on subjective judgments by the investigators. The report specifically found that it is extremely hard to figure out the origin of a post-flashover fire when the fire goes from a localized fire to a much large combustible fire, think fire exploding out of a window, or a fire that has been burning for a long time. Several reports have also noted the endurance of, quote, wisdom passed on through generations of investigators. Old wives' tales about how fires spread and behave that persist in the field. Many investigators have been described as openly hostile to the updated science. Also, from what little we do know, the error rate is very high. In a 2007 unpublished study conducted by the ATF, only 13 of 53 investigators were able to correctly identify the quadrant of origin in a fire that burned for 180 seconds beyond flashover, no better than random chance. Again, research conducted in 2005 revealed that investigators were not able to identify the origin of a fully involved room fire better than random chance. Another 2012 study showed 22 to 26% erroneous conclusions when 587 self-selected investigators working independently viewed photos and data from a fire that burned for only 1 minute over flashover. These results were similar to the 31% erroneous conclusions found in a 70-second beyond flashover study conducted in 2007. Similar experiments occur to this day at the Federal Law Enforcement Training Center in Glencoe, Georgia, with similar, dismal, yet unpublished results. Further, there's a lot of cognitive bias. As discussed above, the main components of fire forensics is comprised of subjective analysis and lacks the components of scientific validity. Nevertheless, it is presented in court as an objective science.
Apart from the cognitive bias and fire investigation community's defensiveness in response to criticism, one of the greatest injustices of introducing this type of evidence into criminal trials is that people have been both convicted and executed because of this junk science. According to the National Registry of Exonerations, at least 63 men have been exonerated of arson since 1991. Unfortunately, was not the case for Cameron Todd Willingham. Cameron was convicted of a triple homicide after his 3 young children died in a home fire. The crux of the state's case was the forensic evidence gathered by fire investigators. After walking through the burnt home, fire investigators concluded that someone had poured liquid accelerant throughout the children's room, even under the beds, and then pouring some more liquid accelerant along the adjoining hallway and out the door, essentially creating a fire barrier that prevented anyone from escaping. Fire investigators ignored evidence. There was a space heater in the children's room that had been acting up, yet they did not write up about anything about the space heater in their report. This case is also an example of witnesses being corrupted. When it became clear that Mr. Willingham was the police's prime suspect, witnesses that had initially said that Mr. Willingham was devastated by the fire changed their story. One neighbor subsequently reported that when Mr. Willingham had cried out for his children, he, quote, did not appear to be excited or concerned. Further, the prosecutor in the case said that in summation that the puddle configurations and pour patterns of the fire were Willingham's inadvertent confession burned onto the floor. Despite the overwhelming evidence of the false and unreliable evidence of arson, Mr. Willingham was sentenced to death, and he was executed in 2004. A commission by the Texas government in 2005, which was investigating allegations of error and misconduct by forensic scientists, found that in Mr. Willingham's case, investigators had no scientific claim for their basis in the finding that there was arson. They ignored evidence that contradicted their theory and had no comprehension of flashover or fire dynamics. They relied on discredited folklore and failed to eliminate potential accidental or alternative causes to the fire. In summary, Texas had executed an innocent man based on the junk science of fire forensics. Thank you for listening. Thank you for listening to our presentation. And although it does seem bleak, there is some hope. Wrongful conviction groups like the Innocence Project have succeeded in overturning convictions based on flawed arson investigations. Thanks for listening, and we hope some of this information will be useful to you in the foreseeable future.